Hello everyone, this is Felix from GM Wolf. Today we're going to be looking how we can make Dithered lighting, which is the effect you can see on screen, where instead of using a alpha mask to change the lighting, the strength of the lighting, we use Dithering to give a nice retro style. Now I actually found this tweet by Pixhammer, which is what inspired me to show you guys how you can make the exact same effects using GameMaker Studio. So in the description below you'll find a GameMaker project file with one background and a sprite. And one of the backgrounds, called BG Dither, is the basis of this effect. As you can see, we have a series of different patterns here that we're going to be using to define our Dithering effect. Basically speaking, we're going to be using the gradient generated by a normal lighting method in order to calculate which of these textures we're supposed to use. So let's have a look at how we can do this. First of all, we're going to create a light object, which is just going to represent each of our lights. So we're going to create a new object here, call it obj_light, give it a sprite like so, and we're going to turn it off the visibility because we're going to be overriding it with our own code. We can press OK, and let's create a new object and call that one obj_lighting. This is what is going to be managing all of our code in order to draw our lighting correctly. So the first step is to create a surface onto which we're going to draw each of our lights. So let's add an event, create. It's going to control and put a piece of code and say surface is equal to surface, let's go create. And we're going to be using the width of the view, which is view_w view, and the height, view_h view. So we can press OK, and now go into the draw event, where we're going to be drawing each of our lights. So let's put in a piece of code. So the first step is to actually set our surface. So we're going to do surface_set_target surface. And if you recall, this piece of code is now indicating to GameMaker that all of what we're going to be drawing is going to go onto that surface. Next, we go with obj_light draw_self to make sure it draws itself. And then we're going to write surface_reset_target. And this is going to be drawing each of the lights onto our surface. Now, before drawing each of our lights, we want to clear the surface so that we have nothing there, so that we have a blank slate to work with every step. And so there's a nice function called draw_clear_alpha, which allows us to say what color we want to draw it, which is black, and what opacity to use, and we're going to be using 1.0. Now, one last step before actually drawing our surface is to change the blend mode. We want our lights to, when overlaid, to add together. We want them to be brighter if they overlay. And so we're going to use another blend mode called BM add. So blend, draw, set, blend mode, BM_add. And before finishing, we want to reset our blend mode by doing draw, set, blend mode, BM_normal. And we can now draw our surface, simply by drawing draw, surface, our surface, which we call surface, the X position 0 and the Y position 0. Now we need to create a room so that we can put everything in. Because this is going to be an effect which is designed for more pixelarity and retro style games, we're going to use a width of 256 by 256. And inside our view, we're going to enable our view, make it visible when the room starts, and the view in room will be 256 by 256, and the port on screen will be 512 by 512. So we can go back into the objects, make sure our lighting object is in here, and then we can start placing a few lights. Now we want to be able to preview how they will be overlaying on top of each other, so I'm going to save a few of them and make sure they kind of overlap. in order to see how the effect will look. So let's press OK, and let's see what it looks like. So now you can see we get our lights being drawn, and you can see that when they where they meet, we get this nice lighting effect where it's slightly lighter. So the next step now is to start chopping up this gradient so that we have different sections to draw different, to choose each of our different parts of our texture. And so the first step in doing so is to create a shader which will band it, which will make a banding effect. So I'm going to call this shd_dither. And we're going to leave the vertex shader as it is, because this is mostly going to be a fragment effect. So let's go into the fragment. We can take this out. And we're going to first calculate the banding effect. So we're going to write float band is equal to the floor of our texture, which I'm going to copy over here and paste right here. So the floor of our texture multiplied by a number. We're going to be using 7 different images, so times 7. However, this here is a texture 2D, which cannot be multiplied by a float. We only want to get the value of that, and one easy way to do so is just to put .r, so we're just getting the red value of it. But because we're working with a black and white image, this is exactly the same as getting its value. So once we have done that, this will essentially raise our range from ranging from 0 to 1 to ranging from 0 to 7. And this doesn't really work inside a shader, so we need to divide by 7.0 again in order to preview it. Then we're going to write over here, replace this with a vec4 with band 1.0. This is to preview our banding effect. Eventually, we will have to change this in order to incorporate our dithering effect. So let's press OK, and let's preview this. Oh wait, before we do this, we need to actually apply our shader. So before we draw a surface, we want to write shader set shd_dither, and underneath it we want to put shader reset. Let's press OK and play. And now you can see that banding effect I was talking about. Now each of those bands are going to correspond to one of the sections of our dithering image. So you can see here there'll be no dots, so there'll be a few dots here and there, etc, etc. So let's press OK, and let's go back inside our shader. Now right now we are dividing by 7.0 again in order to make the image fit back, make the color fit into our range again. However, we want to actually keep this like so. Now we're going to define a couple variables that we're going to be using. So the first being the size of our texture. That is the size of one of the little squares. So if I bring up this background, we want to know the size of this one of these squares. Later on we'll also be looking at the size of the entire texture and the size of, and the relative size of one of these small squares. So first of all, the actual pixel size of one of those squares. So we're going to call that size. So vec2 size equals vec2 16 16, because that is what we're using. The next step is to look at the total size of our image. We're going to be calling this vec2 t size for total size. vec2, and the image we're using is 32 pixels by 64 pixels. This will be used for scaling of texture coordinates correctly. Finally, we have this texture size of our image. However, this we're going to pass in using a uniform. So we're going to put uniform text size, and we need to say it's a vec2. uniform vec2 text size. Right, so now we can start calculating the offset we want to have. So the offset is, let's look at the image, is the number of pixels we want to travel across here and down there in order to get to the texture we want to be using. So to do that correctly, we're going to need a new variable called offset, vec2 offset. And that is going to be equal to a new vector. And the first part will be calculating the x coordinates of our offset. So we're going to take our size of our vector. Yes, I'm missing one part, sorry about that. That is the relative size of this compared to the entire image. As in, this here is half of the image in this direction, and over here it is a quarter of the image. So we're gonna write it over here. Vec2 relative size, our size, is equal to our size divided by a texture size. Now we can start calculating our offset. So our offset is going to be our relative size dot x multiplied by the floor of our banding effect divided by the height, the total number of images we have vertically, which we have 4 of. So let's create that. Let's put 4.0 for now. Actually, we should probably create a new variable called height, so that we know what we're talking about. Height, which is a number of textures in the y direction. So this is our x number. So we have we divide our banding effect by our height, which we then floor in order to get how far along the x-axis we should go. And then same with our y. However, instead of using our floor, we will be using a modulo, mod banding effect height. So this is simply converting a one-dimensional number into a two-dimensional vector along a grid. Now that we have our offset, we can calculate our texture coordinates, which are relative to a single one of those 16 by 16 images. So do vec2 text coord is equal to, again, we need the new vector. So this one is a slightly more complicated concept. You can imagine this image over here. We want to be able to figure out where across this square we are, instead of across this whole image. And because our texture coordinate system works between 0 and 1, we'll have to temporarily move it from 0 to 1 space to pixel space. And then we're essentially going to do a modulo with our pixel space texture coordinates with the size of one of these images, so that we keep on repeating within that one image. This can be done like so. Mod v underscore v text coord not x times text size dot x. This is converting our 0 to 1 range to our pixel size range. And want to do the modulo with our size.x, assuring that we are always wrapping around within the same quadrant of our image. And then we want to divide everything by our texture size dot x times our dither scale, which we're going to set to 2 times 2. We're going to put a comma here and go on the next line to work on our y value. So let's get this nice and lined up, almost. And I believe I have an extra. No, that's fine. Mod double brackets v underscore v text chord. Now we're essentially going to write the same thing as above, but using the y values. Times text size dot y, size dot y, and we want to divide this by our t size dot y times 2 point. So you may be wondering what this 2 is doing here. This is just a simple scale that we can use in order to get our effects to be more apparent, more pixely if you want. The larger this number, the more pixely your image will be. So let's go over this code a bit more because I didn't explain it all that much. So this part over here will convert our texture coordinates from 0 to 1 range to our full pixel size range. Then by doing a modulo with the size, so with 16 essentially, we ensure that it keeps on wrapping from 0 to 16 every time, meaning that we'll stay within the range of our quadrants. And then we divide by our texture size again, times 2, and that allows us to go back into pixel size, into our 0 to 1 range. So as you can see, t size is the size of our actual texture, so it allows us to be back from pixel to 0 to 1 range. Now the last step of the puzzle is to actually bring in our dithered texture, and this is going to be done with another uniform sampler 2D, and I'm gonna call this Dither text. And down here we're going to write glfrag color is equal to the texture 2D of our dithering texture, using as a vector our texture coordinate, that is the texture coordinate within our quadrant, plus our offset that we calculated earlier. And that is essentially it, I believe, for that shader. We can now go inside our lighting object and make sure we have everything set up correctly. So first we must get the texture from our dithering background. So we're going to go dither text is equal to, let's actually stick with GML conventions, is equal to background get texture bg underscore dither. So this is our texture for our dithering. And next we need to get some uniform from our shaders. So we have our uniform for our size. So uniform size is going to be equal to shader underscore get uniform. Our shader was shd underscore dither. And the name, I cannot remember off the top of my head. We chose text size, so I'm just going to copy this and put it within quotation marks, speech marks if you prefer, over here. And here have u underscore text, let's put dither text actually, just so we don't get confused, is equal to shader get sampler index, again shd underscore dither. Let's make this window a bit longer. And our name was, again, I cannot quite remember, dither text. Perfect. So you can put this again in speech marks. We can now go to our draw event, and within our shader set we want to put 2 more lines, one of them being shader underscore set uniform f. So u underscore, let's actually bring up this window here so we can see where we're getting our values from. U underscore size, and we want it to be view underscore w view, view underscore h view, because that is the size of our surface, and shader set, texture set stage. Our sampler index is u underscore dither text, and our texture ID is dither text. So let's press OK and see how this runs. Naturally, we get an error, probably due to not using an index. We can actually see over here inside the compile form that we cannot convert from constant medium int to float at line 8. So let's go to line 8, right here. So as you can see, I am using 4 here for the height. I should be using 4 dot as I'm using a float. That is something that's actually quite different from GML in GLSL, is that it is a type language, and 4 is different from 4 dot. So let's see if this will run now. Perfect, and as you can see, we get our differing effect. However, there is a problem. It doesn't look as crisp as it really should be. And the reason for that is that we still have filtering, we still have linear interpolation going on. And we can fix that rather easily simply by going just before our draw event. We can actually put it right here. Before everything else, draw underscore set texture, and is it not draw? Is it texture set interpolation, and we want to set it to false. And now if we press play, we should be able to see a nice crisp effect with our nice dithering. So this is it for this tutorial, guys. As you can see, it is not entirely too complicated to achieve such an effect. The hardest part is to get our offset set correctly and getting our wrapping to work as well over here. However, this is really it for this effect. All that's left to do now is playing around with the scales until you have an effect which looks about right. Back here I use slightly different values and I got an effect which I'm quite happy with. It doesn't, unless you use exactly the same effect, you won't get the exact same numbers. But as you can see, you can quite quickly work with this system in order to get some very cool retro looking effects. So if you have any questions about this system, please leave a comment down below and I'll make sure to answer it. If you've liked this video and you want to see more, you can like and subscribe, and I'll see you guys next time for some more GameMaker tutorials.